Good day to you. This is a very interesting time here at Anagalactic because we're transitioning to a predictable phase following a discovery phase. And my discovery has not been confirmed. That's just the way it is. You got to get your idea out there. Well, if you're not in the industry, there's no way to do that. In the industry, they have their own clique, their own cadre, they have their own argot. It's completely inaccessible to outsiders. They talk about this among themselves because they're trained to do so. In the same way, basically, you could say that brain surgeons, that's the lab cat, she's allowed in because I need some kind of love there. She's going to her perch there. But E equals mc squared has grabbed the attention of everybody in the 20th century. How do you feel about that equation? Do you understand it? We're going to close on Einstein's famous equation, E equals mc squared, but in order to get it right, to get understanding, I will now be able to explain to you what E equals mc squared means so that you will never forget it. Let's take a look at this two-componency number system that I discovered. A rate is nonlinear. It is a two-component number, not a linear number. A rate is nonlinear. It is a two-component number, which is a proportion. A fraction relates two numbers, redefining each number as a component of one number. This does not evidently occur, that is, with addition, subtraction, or multiplication. We don't use any of those operators to compose a two-component number. Although we're getting to squared numbers in a moment. Squared numbers are very interesting and are very important, certainly in terms of c squared, which is the conversion factor between mass and energy, is a squared number. You don't need the d on squared. It is a square number. A power of 2 number is that number as a square quantity. All right, so the nature of a fraction is to create one number out of two numbers. 1 over 2 relates 1 to 2 in a specific manner, which we call division. So let's read on. We continue to call this relation division because the division operator is used to relate the two linear numbers together into one number. Remember, that is a rate. Here we arrive at another benchmark insight, assisting us enormously in approaching, defining, and using the calculus. Now that we have limited calculus to just the derivative operator, ignoring for now the integration operator, which is the inverse of the derivative, that's called the fundamental law of calculus, we can see that the domain of operation is split into the numerator and denominator. Those are the two numbers being sought for the result, which is a new kind of number. Thus, the derivative is the two-component result of combining two linear numbers to get a rate. The rate is nonlinear, is a fraction, is a division operation, is in fact a relation. The derivative is a rate, a two-component relational number. So far so good, but so what? The derivative is a relational number. Whoever says that? Yet we just proved it to be true. What is the hang-up here? Well, this perhaps touches a bit on sociologic psychology, but we do need to account for this gross error in the teaching of science. No one has ever taught calculus correctly, for this reason, among others. My approach is the only path to defining the calculus understandably. With the calculus, you are seeking that new kind of number, a rate, a proportion. Newton divined the need for this number, so he invented an operation to derive one. He called it an infinitesimal quantity. It is a form of balancing, a form of averaging. What makes it so damn foreign to any of us encountering it for the first time is that it is inventing a new kind of number, the infinitesimal. This is the derivative, the rate, the two-component number, the fraction, the relational number. Now, what we want to answer is this. What is this number providing for us? This is the purpose of the calculus, is to get this new kind of number. So to finish up here, the key here is to be found in the expressor term. That is the term that expresses the meaning. Rate. What the F is a rate? This is the old snipe hunt. What is a rate? To grasp this fully, you must concentrate on getting the full term out of the expressor term, rate. To say rate is to say nothing, at least to a novice. Rate of what? Now we want to keep this abstract as possible. It's rate of change. There is a change being measured. That's the part of the explanation you need to regard carefully. When you take a derivative, you get a number for rate of change. Because this number expresses change, two quantities are needed. That's the basis of relativity. The quantities are at a right angle. They must be, or nothing can be accomplished. So this is an approach to the right angle law. And you know the right angle law, but you've never heard it by that name because that's the correct name for the right angle law. The correct name for the right angle law is the right angle law, but it's most often called the Pythagorean theorem. It is the process taken on a square. The key is to relate the two sides of the square to get a position, but not just a position, because that's a one-component number. A position is a one-component number, even if it's a 3D number having x, y, z components. It's still one number. What is being sought is not the position, but the rate of change of the two quantities of the square, which are its two sides. When one quantity is called x and the other is called y, you try to obtain a relation, either x proportion y or y proportion x. These are equivalent. E equals mc squared. These two terms are commutative. What is c squared? Well, it's c times c. Well, you can write that out. E equals ccm. Now, you could do something quite interesting. E over c equals cm. So light speed is on both sides of the equation when it's written in this form, but it doesn't seem to be too useful. And now we have c over 1 times mass. And now we have an interesting relationship. Multiply energy by the reciprocal of the speed of light. Technical mathematicians off, they don't really like the word unity because it sounds like sacred geometry. It is. So this number is light speed in relation to unity. This is the speed of light expressed in square space. Square space. That is c on the x-axis and c on the y-axis. C on the x-axis and c on the y-axis makes a squared number. Written in scientific notation, it is important to state very clearly that the speed of light is an approximation on an irrational number. Now we're actually going to improve on that. But in order to get to that stage, we must understand what this equation means. It is the equivalency of energy and mass. This statement, in dimensionless terms, is correct. E equals m. But you know you can't really do anything with that unless you have the conversion factor. It gives you the units. The definition of a unit of mass is given in much different units. The way to simplify that, in one sense, a very important sense, was discovered by Einstein, that the coefficient is the square number for light speed. So what is light speed? 1 unit of time, when it's defined as the second, is equal to this meters. So what we can do here is round this. Now you can compute the amount of precision lost here. Now to put it in scientific notation, you count the number of zeros. And how many zeros are there? 8, correct? So e to the 0th would be equivalent to 3 times 1. That's not what it is. How many zeros are in 30? Just 1, right? So that number is the number of zeros following the index. 3 times 10 to the 8th meters per second. And that's easy to figure out. So that's 9 with 16 zeros after that. That is equal to 90 times e to the 15th, correct? 1 less 0 because this is the multiplier and it uses up a 0. If I were to say 1,000,000 billion, I'll bet that you would identify that as a big number. 15 is 6 plus 9. Powers can be added. And this can be read out loud. C squared is equal to 90 million billion meters per second. Now, we have an 8 there. We want that to be a 6. So this is going to be 300 times e to the 6th. And you can read that directly. That is 300 million meters per second. In kilometers, a kilometer is about 0.6 something miles. So it's a large fraction of a mile. E to the 3rd is thousands. So it travels about 300,000 kilometers per second. That's on the order of the distance to the moon. C squared is not at all the same as c times c. Now you may object. That's exactly the definition of c squared. It's c times c. Well, yeah, but that's not arbitrary. That's based on an orthogonal relationship between c and c. You're making a square out of that number, and therefore the units are non-linear. That needs to be disambiguated, but I do want you to see why this is so difficult for physicists to see. I'm sorry for the pun on C, but yes, that is a square number. That is a geometric number. C times C means you go C on the line C times. That's called multiplication. That's not what squaring means. Squaring means C goes this way on the x-axis and this way on the y-axis. And then you compute the volume of the square. And so this is a square volume number. We have taken apart the square in order to put one side of the square, the x, in association with one of the quantities, and so this is c on the x-axis, this is c on the y-axis, because we just took apart the sides of a square number. So this is a form of Albert Einstein's equation of equivalency between energy and mass that I would bet money you have never seen in your life. And yet, it's mathematically equivalent to this. All we did was disassemble this into CC and then moved this C so that it's related to energy, leaving this C related to mass. We then expanded these two terms so that this is now in relation to unity, and this is in relation to unity. And these are called reciprocal numbers, because this number and this number multiply to 1. You may be thinking ahead, you may be brilliant, you may get a lot out of that simple reconstruction, a change of set, a restatement of Einstein's equivalency formula. That on this side of the equation, the coefficient for energy is the reciprocal of the coefficient for mass. And the reciprocity is based on unity around light speed. So light speed must be understood. Here is how this breaks down. C has a specific definition. It's distance over time. That is a two-component number, and therefore we need a reduction. So now we need to reduce these two terms, don't we? We need the reciprocal of distance over time. That would be time over distance. Mass is spherical, energy is spherical. I'm showing you how to convert to spherical numbers. Energy is related to mass on a reciprocal relationship. The nature of spheric numbers is that every single spheric number is a reciprocal relationship. Mass is a spheric number. And we can say one more thing, which is the most important takeaway. Energy is orthogonal to space. Space is already linearized in 3D. That's the definition of 3D. It's the linearization of space. Linearized energy can be one of two things. Time, measured as frequency. That's a temporal term, not a spatial term. And wavelength. So that's the conclusion today. But what does this mean? It means we found where time is. Here it is. This is what Einstein equated with space, where time is 1D and space is 3D. That is the correct linear solution. We're going to be able to understand this in a way that physics has not quite understood. That is the goal of science. The goal of science is just that. So what is time? Space-time artificially inserts time as a 1D dimension. But we can see now that the actual meaning of time, first of all, it is obviously non-spatial. So how was Einstein able to introduce it into a linear equation? It's because time can be proved to be orthogonal with space. But now you have to be careful. orthogonality only occurs, we thought, between linear quantities because it's a right angle, correct? So time is at a right angle to space. That is true the way he did it. But when you take it apart, time has been artificially linearized. What is actually meant by time is frequency. That is time. And therefore time is one of the two derivative quantities of energy. Because energy, we just proved, is a spheric quantity. Time is linear, and wavelength is linear. What nobody has realized is that form of linearity is incorrect. It can be done mathematically, but you'll miss the actual geometric relationship between frequency and wavelength. They're reciprocal. So energy is a spheric number for that reason. And that will be enough because it's getting hot. We're still in the middle of a heat wave. Thank you for your patience. I hope you enjoyed that thus far. I try not to be tedious, but that's 1 hour. In the next video, we'll be covering that in much more thorough detail, where you're going to see some of the most amazing synthetic insights that you've ever experienced or ever will, unless you pursue this the way I do, in which case there is no limit. You will go as far as you want to go, as far as you need to go, and you will not need these mad scientists with their stupid, myopic theories any longer. We need the results that they got, but we also need to interpret the results according to the dictates of rational logic and sacred geometry. Sacred. May the great invisible one bless you with the insights that you need so that you can be pleasing to him because you did what he told you. Learn this if you want to be happy, because then you'll understand. Only you know what that means. No man can share his understanding with another unless they speak the same language. I leave you with that thought. Until next time, this is Anagalactic bringing you the secrets of the universe, and we're entering an election year. You're going to see the name Drake Sterling, my handle, popping up where nobody is going to want to see it. If I don't get disbarred from somewhere, I'm not trying hard enough. This is Hunter S. Thompson, broadcasting to you from a remote location in California. Stay tuned. We'll be right back.